So I just want to talk about ordered and unordered. Okay, so let's just say we have A, B, C. We're just going to start with 3 and A, B, C. So we're going to choose here 2 things from the 3. Okay, and this one here too. Choose 2 things from 3. Now, if we're choosing 2 things from 3 in this first one here, and the order matters, that when I pick A, B, things where the order matters is you might be picking them for a position. Like you might be picking them to be like, say, captain or vice captain. You know, there's 2 different positions. So you could have captain or vice. But for this one, you might be just choosing from those 2 people to just be on the committee. And neither of them have a particular position. So you just want to make sure that 2 people are on the committee. It could be AB or BC or etc. Okay? So the difference between ordered and unordered is with the ordered selection, basically, when you're looking at that, AB and BA are different things, because you'd care if you were captain compared to vice, or vice compared to captain, their actual positions. Whereas if you're just picking 2 people for the committee, AB will be the same as BA. The same 2 people would be on the committee anyway, so it's really not going to matter. So AB is the same as BA. AC is the same as CA. Is different to CA when you're doing ordered, and BC is different to CB when you're doing ordered. When you're doing unordered, AB is the same as BA, BC is the same as CB, and CA or AC is the same as CA. Okay, so you notice here that there are 6 possibilities. Whereas this one here, there are 3 possibilities, because they mean the same thing. When you choose 2 particular people, you're just choosing those same 2 people. Doesn't matter which order you actually choose them, they're still on the committee. Okay, so you've got 3 possibilities here, AB, BC and AC. And here you have AB, BA, AC, CA, BC and CB. So that's where the order actually matters, and that's where it doesn't matter. Okay. All right, so looking at this here, I just want to show you with, if you look at this, when you're doing ordered, so this one's the ordered one. So when you're doing ordered, it's good to do the box. Now, if you've got 3 people and you're picking 2, like you're choosing 2 people and you matter about order, if you draw a box, there's 3 choices for the first person times 2 for the second, which equals 6. See how that matches my 6 possibilities here? Okay, and I just want you to realize too, you know how I was saying before, that's actually, there's 1 factorial missing there. 3 times 2 times 1 times divided by 1 factorial. I know it doesn't look like it, but I'm going to do this on 4 in a minute, it'll make more sense. See how that cancels out? So it's like 3 factorial, 1 factorial. Okay, and you end up with 6. When I do it on 4, that will make a little bit more sense. When you're over on this one, and you've got 3 possibilities, then the order here is not going to matter. Okay, so if we're choosing this, what we actually need to do is we do our 3 factorial, but what we're doing is we need to divide out the AB compared to the BA. So what you do within themselves, when you choose those 2 people, you've got to divide out the number of ways those 2 people could be arranged within themselves, which is 2 factorial. And if you look at that there, what I'm cancelling out is, if you cancel this out, that's that you cancel it out, you end up with 3 ways, which matches what I have up the top here, that there was 3 ways for this one, and there was 6 ways for the other one. So it just has cancelled out the 2 factorial, and the 2 factorial is counting the number of ways within the pair that you picked. Okay, so if you're looking at, I'm going to look at when we go up to 4 now. So we're going to do 4 people, and we're still going to choose 2. And we're going to put them into the position of vice captain, of captain and vice again. So your first choice would be, you have 4 people you can choose from for captain and 3 for vice. So you end up getting 12. Now, I want you just to realise that that has the tail end of that factorial. If you put the whole 4 factorial, that's 4 factorial, the 2 factorial is actually divided out of that. So it's actually 4 factorial on 2 factorial, which gives you 4 times 3, which gives you 12. Now, we'll come back on that in a minute. So the difference with this one here, when we're choosing the 4 people, when we're going A, B, C, D, we're taking into account that A, B and BA are different options. BC and CD, CB are different options, etc. I won't write them all out because there's actually 12 of them. You could do C with D, so C with D, C with B, C with A, and then do it all the other way around as well. A with C, A with B. So when you're writing out all those different options, A, B, C, D, we've done all the A's, A, C, C, A. So when you're writing all of those out, then basically when you come to ordered and you're just choosing 2 people for your committee and the order doesn't matter, then AB is different to the CB. So you actually have to divide out the 2 factorial. AB is different to BA, you have to divide it 2 factorial that each pair can be arranged within each other. Okay, so you're doing the same thing, like you got your box and you go 4 times 3 choices, okay, but then what you need to do is you need to divide by 2 factorial, and there'll actually be 6 ways. There'll be 6 ways because you do like A with B, A with C, A with D, okay, they're different ways, and then we go, and then let's go B, let's do B, so go B with C and B with D, and then you go D with C. Now, you can't do D, D's gone with every single one, so if you think about that, let's go, you got D, D, so D goes with A, B, and D with C, that works, and has C gone with everyone. C's with A, C with D, and C with B, yeah, because there's 3 other letters. A has definitely gone with A with B, A with C, and A with D. We're just not doubling up. And B, has B counted 3 times? Yep. You got B with C, B with A, and B with D 3 times. So if you look at that, that's actually 6 ways, isn't it? And I just want you to think about this further on. Like if we look at this one here, which we call the permutation. The permutation was, when you're looking at that, was equal to, so the permutation for this was equal to 4 factorial on 2 factorial. And the only difference between the permutation and this one over here, where the order matters, so the order doesn't matter, would be you do 4 factorial on the 2 factorial, and then what you do is you divide by an extra 2 factorial for the number of ways that you're choosing it. So there's 2 in the group. Now, we call this one here is called a combination. And there is actually a special button for working this out. It is called your NCR button. And if you look for that, I think it is on top of your division sign. You just have to press a shift to get to it. And I want you to now try in your calculator, if you went 4C2, because you're choosing 2 people for a group from, so you're doing 2 people for a group, and you're choosing it from 4 people, that would be 4C2. And 4C2 is 4 factorial, 2 factorial, 2 factorial. And if you're choosing this and you put this in your calculator, you will get 6. This one here is a permutation. So it is a P button because position counts. So it's P for position. And a position, when position counts, we call that a permutation. And a combination is more like when you're choosing something for a committee. So think of C for committee. And that's why it's NCR, whereas this one here, you try 4PR, which I think it's on top of the time sign, NPR. If you try that, you will see you will get 12. But I want you to realize that the only difference between these two scenarios is that the combination one is dividing out the number of ways that the group can be arranged within itself. So the two that you choose can be arranged within themselves. So if you were choosing not 2 and you were actually choosing 3, then how many ways could that be chosen within themselves? You'd have to divide out 3 factorial. And a quick and easy way for the committee one is using the NCR button. I don't particularly like using the NPR for position. I would prefer you use the box method. It is your choice. Some people are very good at that. But when you have restrictions, just simply learning the NPR button causes a lot of problems. You're better off fixing, in this case, you fix your restriction, and then once you fix your restriction, then you just multiply all your possibilities. Whereas the NCR button, that can be used directly because all it's doing is dividing out the number of possibilities which within the group that you picked in the smaller group.